It says, what mass of carbon dioxide can be produced from 25 grams of calcium carbonate given the composition reaction? And they're giving me the reaction. The first thing that I have to see is that if it's balanced. So I have one calcium and one calcium. I have one carbon and one carbon. And I have 3 oxygens, and I have 1 plus 2, 3 oxygens. So the equation is already balanced. You don't need to do any balancing procedure. Okay, let's try one more time. Okay, so the equation is already balanced. Okay, we already checked. And they're asking you about what mass of CO2 from 25 grams of calcium carbonate. So for this example, they're asking you grams and they are giving you grams, which means that you have to do a grams to grams process. So what I do is I take the givens, take the molar mass. I'm going to write the equation again to put all the information that I need. Okay. Okay, I'm not going to calculate the molar masses because I think it's a procedure that you already know how to do it. So for calcium carbonate, I have a mass of 40 plus 12 plus 48. Calcium 40, carbon 12, and 48. So it is 100 grams per mole. Calcium oxide, it's gonna be 32 grams per mole. And CO2 is going to be 44 grams per mole. Okay. Yeah, I have a mistake in this one. Well, let's continue, okay? We begin from the given. They are giving us 25 grams CaCO3, okay? You know that when we have this kind of process that is grams to grams, we need to do we need to write the path, okay? So I'm going just to bring the path from another exercise and I'm just going to paste it. Okay, that's the path. From grams given to moles unknown to grams unknown. So we start from that. I need the molar mass of the given. So the molar mass of the given is 100 grams CaCO3 in 1 mole CaCO3 times. From moles given to moles unknown, I need the molar ratio between calcium carbonate and CO2 because that's the question about, okay? So the molar ratio, as you can see, is 1 against 1, okay? 1 to 1, mole CaCO3, and your mole of CO2. And then in the last step, what I do is the molar mass of the unknown. In 1 mole CO2, I have 44 grams of CO2. How much do you get from this?
11 grams of CO2.
Okay. So 11 grams of CO2 means that the right answer is letter A. That was part of yesterday's quiz, but instead of 25 grams, I wrote 50 grams, but the procedure is exactly the same. So in yesterday's quiz, the right answer was 22 grams. Okay. Well, um, so let me. It says 125 grams of copper are reacted with 50 grams of chlorine gas. And the reaction is Cu plus Cl2 produce a copper 2 chloride. Okay, so the first thing that we need to do is make sure that the equation is balanced. We have copper and copper, 1 and 1. We have 2 chlorines and 2 chlorines, which means that the equation is already balanced. Okay, so they're asking me to get the theoretical yield, to tell which one is the limiting reactant, and to get the percentage yield if 80 grams were obtained in the lab. Okay, so that's all the information I have. And what I do now, I'm gonna write the equation again so I can write all the data that I'm gonna find useful for solving this problem. So I have this, I'm just going to write the information given. They are giving me 125 grams of copper and 50 grams of chlorine gas. And I have the molar masses of copper is 63.55 grams per mole. Chlorine, I have 2 chlorines because it's diatomic. I have 70.90 grams per mole. And copper chloride will be the addition of the two, 134.45 grams per mole. Those are my molar masses. I'm not gonna do the procedure for that because of the time, and I think that you already know how to get it. Okay, so take a look. The procedure I have to do is they are giving me grams and I'm asking you, okay, the theoretical yield, and the problem is mentioning also grams, which means here again we have a grams to grams conversion. Okay, so you know this is the path. I'm just gonna copy and paste because I'm that kind of lazy. So here you have the path. From the path, we can start working on the problem. I have the two givens, copper and chlorine, and I have the amounts. So I begin with copper. They're giving me 125 grams Cu, and they're also giving me 50 grams diatomic chlorine. Okay, so I begin with that. My first conversion says that I need the molar mass of the given. So I say there are 63.55 grams of copper in 1 mole of copper. Okay, that's my first step. Then it says that I need molar ratios between the given and the unknown. So all my ratios are invisible ones, okay? So this molar ratio is actually 1 against 1 mole of copper against 1 mole copper chloride, copper 2 chloride. That's why this exercise was easy, because the molar ratios are 1 to 1. And then in the last step, the molar mass of the unknown. Okay, so in 1 mole of CuCl2, I have 134.45 grams of CuCl2. How much do you get from this?
264.23.
264.23 grams of CuCl2. Okay, so we need to compare to the next one. So we say 50 grams of chlorine, according to the path it says I need the molar mass of my given. So in 1 mole of chlorine diatomic, I have 70.90 grams of diatomic chlorine. The molar ratio, as we know already, it's 1 to 1 because all the coefficients invisible ones. And then in the last step, I have the molar mass of the unknown. So 1 mole of CuCl2, 134.45 grams CuCl2. How much do you get from this?
94.82.
94.92 grams.
82.
82. Now with this, we can say how many grams can be produced, 264 or 94?
The limit reactant.
94.
The list of the answers. Okay. Okay. So with this, we say that they can be produced 94 grams. And what is the limiting reactant?
94.82.
Yeah, the 94 are the grams that can be produced. And the limiting reactant is the element that produced that amount. That is, chlorine is the limiting reactant. So with this, we already answered 2 questions, okay? The theoretical yield, 94. And the limiting reactant, that is chlorine. Now, we need to get the percentage yield. So we say percentage yield equals actual divided by theoretical times 100. The actual is what you get in the lab. The theoretical is what you get from the limiting reactant. And you will multiply times 100. So this is 80 grams that you got in the lab divided by 94.82 that you got from the limiting reactant times 100. How much is this?
84.37%.
Well, 84.37%. So with this, you have all the information required to answer the question. So the right answer is the third one. The theoretical 92.82, 94.82, sorry. The limiting reactant is chlorine and the percentage yield 84%. So as you can see, all these matches the answer that we got. That was the first exercise. If you have any doubt on this exercise, let me know. I'm bringing the second exercise. Okay, I move on to the next one. It says, when copper 2 chloride reacts with sodium nitrate, copper 2 nitrate and sodium chloride are formed according to the formula that you see over there. balance the equation, etc., etc., etc. If 20 grams, chalala, chalala, react with 15 grams of sodium nitrate, how much can be formed of NaCl, which is the limiting reactant, and how much of excess reactant is left over in this reaction. So what I do in the first place, as I told you, I write down the equation. CuCl2 plus NaNO3 produce CuNO3 2 plus NaCl. The first thing I have to do is check if it's balanced, okay? It's not balanced, so I have to balance it. Take a look. Here I have two nitrates. So what I have to do to balance is writing 2 in the other side. Because now I have two sodiums. I need to balance this in the other side. Now my equation is balanced. Now I continue by getting the molar masses. So this molar mass, I got it from the exercise before. It is, I think this one is 134.45 grams per mole. This one is 85 grams per mole. This one, I don't know. But this one is 58.44 grams per mole. This one is 187.55 grams per mole, though I didn't use it, okay? I just like to write all the information in my equation. Now, what are the givens? They are giving me 20 grams here, and they're giving me 15 grams of sodium nitrate. And they're asking me about sodium chloride. Okay? Also about the limiting reactant, etc., 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 and the leftover. So the procedure is, as you know, very similar to the ones that we have been doing so far. So I begin with my givens. Okay, so I begin with 20 grams of CuCl2. Okay, again, it's a grams to grams procedure, which means that we need to do the path. The path is the same one over here. Ay, puedo copiarlo, ¿por qué? Let's see. Sorry. Technical issues. Okay, there you go. I have the path over there. Oh. Okay. So I begin with my procedure. Guys, honestly, it's that the path is very useful. If I don't have the path, it's a little bit more difficult to do it because the path tells you exactly what to do. So in the first step, I use the molar mass of the given. So the molar mass is 134. 0.45 grams CuCl2 in 1 mole CuCl2. Okay, now the next step is molar ratios between CuCl2, and NaCl. Okay, so the mole ratios are 1 to 2. 1 mole CuCl2 against 2 moles NaCl. And in the last step, the molar mass of the unknown, that is 1 mole NaCl, 58.44 grams of NaCl. How much do you get from this?
17.38.
17.38 grams of NaCl. I continue with my second reactant, that is NaNO3. So the problem gives me 15 grams. And I will do the same procedure. Okay. Molar mass of the given, that is 85 grams. I want to make sure of this. 14 plus 48. Yeah, 85 grams of NaNO3 in 1 mole NaNO3. I continue. Molar ratios. Molar ratios between the second reactant and NaCl. As you can see, the two coefficients are 2 against 2. That's all that matters, okay? 2 against 2. And then moles of sodium nitrate, moles of NaCl. And in the last step, the molar mass of the unknown, that is NaCl, 58.44 grams. How much is this?
10.31.
10.31. So here, how much can you produce? 10.31. So which one is the limiting reactant? NaNO3 is the limiting reactant. Okay, with this, we already answered two important questions. Now, well, students from the other section, they told me that they prefer to do that quiz on Monday. So I assume that, what are you going to choose? Monday or today? Physics quiz.
Miss, but on Monday will be at morning or at
No, in the afternoon. Both are gonna be in the afternoon. Okay?
better today.
Better today. Okay.
On Monday, Miss.
Yes, Miss, on Monday.
Monday.
Why, but yeah,
Monday.
okay, Monday.
Yes,
Yeah,
Monday.
most of you said
Monday.
Monday, so it's going to be Monday. Okay, let me continue with the exercise. They're asking me about the leftover. Okay, so for the leftover, as I already taught you how to, okay, for the leftover, you need to relate the limiting reactant with the excess reactant. Okay, that's a relationship that we have to do. So the limiting reactant we know is NaNO3. Okay, so we're gonna start with that given. 15 grams of NaNO3. And we're gonna do the same procedure. It's not updating. I hate when this happens. Let me try something. I know. Guys, do you listen to me?
Yes.
Yes.
I know this is not updating. When? La vieja confiable. Okay, so I have the 15 grams of NaNO3 and I'm going to do the same procedure, okay? Molar mass of the given, molar ratio, molar mass of the unknown. So molar mass of the given, you already know, 85 grams NaNO3. Now it comes the molar ratio between the limiting reactant and the excess reactant. So the molar ratio is 1:2, okay? So you say 2 moles NaNO3 against 1 mole CuCl2. And then the molar mass of the unknown, that is in 1 mole CuCl2, okay, I can't, not, sorry. 134.45 grams of CuCl2. How much is this? How much is this?
11.86.
11.86. So how can I get it? This is what you used, okay? This is what we know as the amount used